Good day. How can we protect the ocean when it is so vast? Illegal fishing is a major threat to ocean sustainability. I'm Tia Hobson, a fisheries analyst at OceanMind. Modern satellite capabilities to detect global fishing activities. Over the past 10 years, satellite capabilities to support maritime domain awareness has grown substantially. There are now more operational satellites in orbit than ever before, with a vast array of sensors with widely varying capabilities across the spectrum. The number of these cases that can be supported by satellites is almost endless, and the vast ocean of data is created and impossible to understand without computational assistance. Artificial intelligence is now vital to understanding activities and trends affecting ocean. This presentation explores the capabilities through the application to the maritime awareness of fishing activities, examining the data for its relevant end users and how machine learning is essential to support human decision making. According to the latest official figures, 33% of the world fisheries are overfished and are unsustainable. 60% are maximally sustainably fished, meaning that sustainable but being fished at maximum capacity. However, official figures are unable to assess the realistic level of illegal, unreported, and unregulated fishing in the fishery, meaning that these figures could be worse than what the trend suggests. With 3 billion people relying on the seafood as a source of protein and 12% of the world's population relying on seafood industry for their livelihood, we stand on the brink of the world crisis. OceanMind is a not-for-profit organization with a mission to empower enforcement and compliance to protect the world's fisheries. Our work helps preserve marine biodiversity, protects livelihood, and prevents slavery in the seafood industry, using satellite and artificial intelligence to identify fishing activities and suspected non-compliance. Every day, the team are contributing to work that changes people's lives and helps protect the ocean. OceanMind uses technology to securely and confidently bring together every data source needed to understand compliance of fishing activities. This includes vessel tracking data, satellite observations, local observations, port data, catch documentation, vessel registry identification, fishing license and authorizations, and a proprietary database of thousands of fishing rules and regulations. Our technology creates prioritized alerts for our in-house expert fisheries analysts to review and investigate, which we then deliver to authorities and seafood buyers as actionable insights that include recommendations. In partnership with Microsoft, we deliver artificial intelligence models to identify specific fishing behaviors and gear usage that is fed into rules and regulations engine to automatically identify suspected non-compliant level at scale. OceanMind uses the five stages standard intelligence cycle to develop and drive our analytical support. The first stage is an approach and planning we carry out with a comprehensive review with experts in an area of interest and the fisheries. Our second stage is to gather raw data from a conceivable source. The third stage, to process the data ourselves through machine learning or computational analysis and identify activities of interest. A fourth stage would be the analysts and expert fisheries monitoring and compliance to conduct an in-depth analysis establishing significance and implications for indicators of non-compliance and also situational awareness of other activities. The fifth process is the intelligence reports with specific recommendations that accompany a comprehensive assessment that is provided. This is an example of a vessel that is operating on the high seas. As you can see, there is alerts, and these are the kind of tools that our in-house team of analysts use to analyze the data. We also have databases for the identities for the regional fisheries management organizations and illegal, unreported, and unregulated databases. We continuously cross-check our data sources and get updated. The vessel tracking systems that we use is a combination of automatic information system, AIS, which is both satellite and terrestrial based, and VMS. We also are able to use environmental and oceanographic resources within our system, as well as having computational algorithms and machine learning, which assist us analysts while doing the analysis. A key tool for us in combination with the vessel tracking is sympathetic aperture radar, or SAR, and it allows us to locate dark vessels. SAR can be used in various models, such as a wide area vessel detection mode that can find vessels over 20 meters in length, which can be obtained both commercially from the government or from can be contained commercially or from a government source for free, such as the European Space Agency. Other modes include a small area vessel detection that has a much higher resolution and can find vessels over 5 meters. This is typically only available in commercial. This radar image was from Maxar. It is such an image that clearly shows the location of vessels outside of Port of Asia. The vessel detections from SAR images can be correlated with vessel data tracking, and to identify and correlate which vessels these are. We also use electrical optical. Here I have an electrical optical image. This image shows a transshipment at sea in progress that was identified through the analysis of the vessel tracking data. This is a high-resolution image from digital codes at 50 centimeters resolution. This was taken several years ago and is possible to get high resolution now. This image is you are able to see a refrigerated cargo vessel alongside a typical longliner vessel. This resolution, as such, is possible to make out and identify the vessel with such a deck layout and the number of cranes on board the refrigerated cargo. A practical use for this data is to understand the fishing vessels are meeting up with carriers while at sea. Often transshipment alerts will be triggered while we are busy tracking the carrier vessel. If a satellite can be tasked to take an image early enough, it can be possible to observe both vessels as such depicted in this image. Another data source that can be highlighted is the Visual Infrared Imaging Radar Suite, VIRS, from NASA. It collects visible infrared imagery and radiometric measurements of the land, atmosphere, chromosphere, and oceans. It is designed to detect reflected moonlight from clouds to map cloud cover on a nightly basis. Where there is no cloud cover or moonlight, it detects vessels that are using bright lights to attract fish. To illustrate the photo shown, was taken by Tim Peake, a UK astronaut, from the International Space Station. The green dots are fishing vessels attracting particular fish. As with SAR, we can correlate these detections with vessel tracking data to identify vessels or locate dark targets. As a practical example, we use VERS as a low-cost data source that provides nightly coverage of most of the UK overseas territories, which help detect illegal fishing in our marine protected areas. To illustrate each of the green dots in the previous photo, here is a vessel that looks of what the vessel would look like. And I'd just like to say thank you very much for listening to my presentation. If you have any questions or want to find out more about OceanMind, please email us at info@oceanmind.global or go onto our site, OceanMind. Thank you.